Hello, my name is Rainer Hanekamp. I'm a trainer and consultant at Angular Architects, and this video is not about Angular, but it is about in my opinion, the most important TypeScript skill for application developers, and that's type narrowing. Now, what's that? Let's say we have a variable that has an unknown type or has a union type, so we don't really know what type it is, and that happens actually quite often. Now, we have a set of techniques, we have a set of checks that are called type guards in that case, where we can narrow down, as the name says, the multiple types to a single type only. And that's not all of it, because we are working here together with the TypeScript compiler, because the compiler can check, analyze our code, and can guarantee us that the implementation is really correct and that the single type that we ended up with is really correct. There is also a very similar technique which is called type assertion, where we are not working together with TypeScript, because with type assertion we just define that although it could be multiple types like string or undefined, but there we just say, okay, it's just string, and we don't give any reasons or any checks. This is not good because in the end we are trying to be smarter than the compiler in that case, which is never a good idea, and in the end it's not a very type-safe way. So type narrowing in that case is really superior to type assertion, and that's why we should always try to use it. And now let's take a look at an example. Alright, so I have here my TypeScript file, and I say I have a function which is called calc_h. It should return a number, and the parameter for that will be a value, and the value can be of type date, could also be of type null, or even an undefined. Now the problem is, as we all know, if I use here the diff in years, the function that can actually do the actual calculation, and I pass the value to it, then TypeScript starts to complain, because TypeScript's now saying, hey, look, this will not work. The diff in years function wants to have a date type. You have just passed me a union type of it. That's not going to work. And what you could do now, but what you shouldn't do, is that you apply type assertion. Now with type assertion, I would say, look, the value is type date. I'm saying this now, and I'm now more or less overwriting the TypeScript compiler itself. I'm outsmarting it, or I think I'm clever than it is, which is never a good idea. So be careful with this approach. This is type assertion, and it's kind of cheating. So I would say don't cheat in this case, and try to come up with alternative solutions. What can they be? Well, an obvious one could be that we just verify if the value is not of type date, is not of type null, and also not of type of an undefined, and then it can only be date, and then we are quite safe. So the way I do this is that I say, okay, value should not be null, and it should also not be of undefined. And then we could say, I'm going to comment this out, and then we could actually say, okay, now it's actually safe to use type assertion, because obviously looking at the code, value can only be of type date. We know that. It's not just us who knows this. It's actually also the TypeScript compiler who is aware of that. TypeScript compiler understands this if condition and the consequences of it. That's why I can just remove the type assertion here, leave it as it is, and if I go with my mouse over the value, we see it's actually only of type date, because TypeScript understands it. So I can remove it, and it's a very type-safe way in that regard. Another approach might be that we say, okay, I don't want to come up with all these if conditions here. I want to make it a little bit shorter. Now, there is this type of type guard, and the type of type guard returns us the name of the type, and it returns us the full name or the real name if it is a primitive type, and if not, it just returns object. Now we can now make use of it, because Null and undefined, they are actually both primitive types. So in JavaScript we have as primitive types, we have 7 of them. We have the string, we have the boolean, we have the number, we have the null, the undefined, and we also have a symbol and the big int. So the way how it would work with the typeof operator, that I say, okay, what if type of value, what if it is an object? Because this is what date is. It's not the primitive type, it is an object. Would that work? No, we see it already. And the reason is not because date is not an object, or value is not an object in this case, that's true. But there are, with the typeof, there are 2 exceptions. Because for the null type, the typeof always returns object as a string. This has historical reasons. That's just the way it is. We have to accept it. We have to be aware of it, and then we are safe. And the second exception is not of interest in this case, but typeof can also return function as a string, although function, strictly speaking, is not a type in JavaScript, because a function is a callable object. So normally it would be actually object and not function. But that's not important here. The more important thing here is how are we going to deal with the null value here? Because clearly, if we go with the mouse cursor again, and the TypeScript is telling us what it thinks that value, what type value has here, it says, well, it can be date, yes, but it can also be null. Type of value can also returns also object for null. So this is not a very good, very solid solution, I would say. And what we can also apply, maybe we come back to the typeof operator later, but what we could also apply is a truthy or falsy condition. So we know that there are certain types in JavaScript that will also return a false if used in an if condition, and they are the null or the undefined. This is the number 0, the empty string, and also not a number, which is a special number type. So we could actually make use of that. So I can say if the value is a truthy value, which can only be the case if it is of type date, because otherwise it's null or and undefined, then I'm quite safe. TypeScript also understands this kind of type guard and says, yes, you're right, in this case it could only be of type date. Great. Just going to save it. And now let's say we are getting a 4th type. So I say here it could be of type string, would be the 4th type, which is possible. What are we going to do now? Well, now we could actually perfectly use the typeof type guard again, because we can check if it is really a string or not, and then otherwise it will be, of course, of type date. Now the way how it would work is that, first of all, maybe let me just switch it. So I say here, if it is null or undefined, then I'm returning null as value. Might not be optimal, because maybe I don't want to return anything if it is null or undefined, but we'll fix this later. For now, I come up with a second if condition, and here I use typeof again, our old friend, and I say, are you of type string? And if that's the case, then I can say, okay, then I need to pass it, of course, I need to pass the value, that's why we have this function for, and then I just return the diff in years. And otherwise, so the last else must actually be the case that the value is now only of type date. So which this means I'm just returning diff in years, value, and that's it. And we see TypeScript's not complaining. We can go with our mouse and check for the types. Yeah, inside of the else if, value is of type string, and here it's of type date. Great. Not really great. We have missed maybe one important thing. If the value is an empty string, then we would also end up here returning null, but in this case it might be acceptable. Okay, so far so good. What might now also happen is that we have something, a class, a new class of type person, and this class has a birthday property, which has the now date, so let's just assign a value to it. And of course, this class or an instance of this class can now also be passed like this. And we see already in the else, we have already a compilation error. TypeScript now says, hey look, you have a date or you have a person, so you can't just again call the diff in years. You need to be more precise. You need to give me another type guard in order to understand if it's a date or if it's a person. Can't be two things at the same time. Now what we could use here, because it's not, both are not primitive types anymore. Both are actually instances of classes. And we can make use of that because there is a type guard which is called instanceof. And with instanceof, we can request against every value if it is an instance, as the name says, of a particular class. So I would come up with another condition here, and I would say, value, are you actually an instance of date? Instance of date. If that's the case, then it's fine. Otherwise, as we did before, we know it can only be a birthday, can only be an instance of type person, and this means that the value must have, as we see it here, a birthday property of type date. Okay, so value is date, and here it's a person. But that's not all of it. Let's start to make it a little bit more complicated. Let's say I have, it's not a class, but maybe it's a type. Okay, and maybe let's say, let me just fix it. And let's not just say there is just one type person, but maybe also there is another one, which is called type car. And both types are possible. Now the car will not have a birthday. It's a little bit ridiculous. Say, let's say it's a construction year or year of construction, but it will be a date. And now I say I want to pass the person, the car here as well. Now the nice thing is we can get away for the date itself. So the date instance of date will always work. But what we cannot do is that we say, are you, or let's just leave the date as it is, that's already working. We cannot apply the instance of against the type, because I cannot say value instance of person, because now TypeScript tells us, hey look, the person here, this is actually a type. A type is something that only I know. JavaScript does not know of any type, so that the code for the type, it will be removed. So you cannot use that type in a code that should actually be executed in JavaScript. This will never work. And because of that, the instance of cannot be used anymore. Now it comes even worse. Both of them are objects, so we have three object types, so we cannot use the type of either. It's not that easy in this case. There are no multiple solutions available. First one, if we are lucky, if we are really lucky, it could be the case that the person has a discriminator property. In this case, I would say, okay, we have a type, and I say the type is actually of type person, and here the type could be of type car. Now, if that's the case, then TypeScript understands this again, and it says, okay, you are here more or less in the else if, and here the question is only, are you of type car or are you of type person? I see that both types have a type property, so this means you can actually access it. You can access type, this is type safe, it will be there. And now I can say, are you, does this type property has the type car? Now TypeScript says, okay, there is just one type that has this value, and because of that, I can here say, okay, year of construction, here it's available, and then again, as we have done before, we have our final else, where I say, here the value will be of type person, so that's why I'm returning here the birthday. Okay? If we are not so lucky, and if the type is not available, then we have another option. The other option would be that I say, okay, just removing the type. I know that the birthday is only available in person, so I can actually do a check if this property exists. And this is the in type guard. So So I could say here, instead of value type is car, I can say the property birthday is this part of value within. And TypeScript says, okay, if that's the case, if this is true, then the value in this case can only be of type person, and here again we have the car. So here the value is of type person, and here it is of type car. Wonderful. So very easy if we know this property can only be available in this type, and in the other it's missing. But that's not always the case, as we know. It can be a little bit different. As we know, in JSON, when we are getting data from a backend, there is no date type available, so I cannot place a date type inside of a JSON. So let's say I have a person JSON, and it has the same name, it has birthday, but it's of type string. Person JSON. What are we going to do now? Well, actually, we could apply the typeof again. So I can say, okay, I know both of them have the property birthday, but only one of them can be of type, so the birthday property, only one of them can have the string as type. So I can say here, instead of using the in type guard, I can say value, birthday, both available, so that's type safe. I can say typeof, birthday, is it a string? And then it's clear for me that it can only be a person JSON. So I can say here, okay, then I need to parse it, then I return it, and if that's not the case, then I just use birthday like this. And this looks like it is working. But if we take a look at the value itself, then we see that it says here, oh, the value can be of type person or person JSON. Nevertheless, because we have done the check if it is of type string, TypeScript allows us and says, yes, that's right. But if we want to do a little bit more with this value here, for example, let's say I could also, maybe I want to return the person, so just a thought experiments in this case. Maybe I want to say the function could also return a person. And at this stage, I say, okay, I return you the person, and it will not work because the value is not, sorry, not here, but maybe here. Here it is a person, or it should be a person. Oh, sorry. Okay, now it's fixed. And we see here a problem, because it says, hey, look, this is not a person, it's still the union type. And this is where we have more or less reached the limitation of TypeScript itself. It might be the case that in version 4.9 it will be fixed, so I'm running here in 4.8. But regardless of that, there will always be some cases where we reach the limits of TypeScript, and then we have to do something else. And that something else is called a type predicate. So this is a special function where we can more or less work together with TypeScript. So in all these cases where we say, I need to come up with a special logic that TypeScript can't follow or can't infer anymore in order to come up with the real type, then TypeScript gives me this opportunity. It tells me, look, you can write a type predicate, then you have part of the responsibility lies with you. I'm trusting you in that case. So it's a kind of a mixture, a kind of a compromise. And the way how a type predicate works is, as I said, it's a normal function. So I can say it is a person. I know that the person can only be, or I'm defining here that it can only be of type person or person JSON, and I can now return a Boolean. So this is what the function returns. But since this is a very special function, I need to do something else. I need to say the return type actually defines that the person is, or that its value is of type person. It looks a little bit strange if you see it for the first time, but this is a type predicate. And I need to return a Boolean, because otherwise it's not working. So I could say now, okay, although TypeScript doesn't really infer it, but I can say the type of value, so in this case not type value birthday string, but I do it the other way around. I say value birthday instance of date, because then it's a person, then it's of type person, instance of date. And then I just call the function as any other function. So I say here, else if is person, pass the value to it. Then of course I've mixed it up a little bit. But the nice thing is, this return value, this return of the person which failed before, is now working. Of course this return is not working because I've just returned something. But now it's really type safe, and I could also do something else with the person if I want, because it's not a union type of person JSON anymore. But this was just a thought experiment, as I said, so I'm going to remove it and leave it for now. Okay. So about these type predicates. These are things that you really need more or less in very complicated and complex cases. I mean, we can actually exaggerate it a little bit. We could say that the calc_h function doesn't know what it is. It's just an unknown. That's the worst case. We see some of the type guards that we have here in place. They are working, but not all of them. And then you will have to come up with these kind of type predicates quite a lot. Now, if I want to write a type predicate where I say, I don't know the type, so the type can actually be unknown, but I want to be sure that it is really a person, or at least that it has a birthday of type date, then I need to write quite a lot. So I need to come up, first of all, I need to check if the person is a true value. So I say here, if person actually exists, or I say just type of person, let's go like this, type of person is an object. Good, then I'm excluding all the primitive types, but not all of them, as we have seen before, because the null is still available. That's why I just say person shouldn't be a null. Good, then I know I have an object. And now I can continue. I could continue now with the in type guard. So I could check if this person object actually has a type of a property of type birthday. So I say here birthday, are you actually in that person? That's not all of it, because I also need to check if the birthday is of type date. Now there's a problem. I can't just write something like this, type birthday, instance of date, because TypeScript, again, kind of a limitation, because TypeScript doesn't really understand, hey, you have to, that I have just checked for the existence of the person, and then I want to use it later on. So TypeScript has here a problem. Maybe, I mean, definitely it will be fixed in the future. TypeScript is continuing to improve. It's always getting better. But for now, I need to do something which, again, I defined before as cheating. So I need to apply here a small of type assertion. And I say here, yes, there is a birthday inside, or this object is an object literal that has a birthday property, but I don't know the value. That's for sure. And well, I'm having no problems with my keyboard, and I need to change it a little bit like this. And then I kind of have a check, a type safe check, that at least the birthday property is of type date. This, if we are very strict, this doesn't really mean that it is really of type person, but for our use case, let's say it's enough. It's already quite a lot, and let's say, okay, this is something we accept, and it's just fine. Nevertheless, I wouldn't go so far. I wouldn't come up with all these complicated logic when we're dealing with unknown types. There is a library available which I want to show you, and what I would also recommend, that will take care of that. And this is a library which is actually very popular at the moment, and this is sort. So with sort, I can define a schema for any type, and also for person in this case. And the way how it works, that I say, first of all, I have this person schema, and then I use set, this is sort, I say I have an object, schema of an object, and it should have a birthday property, and the birthday property is actually of type date. So now the rules for the schema are inside of this sort generated variable here, person schema, and I can use this now in my type predicate. Very easily, I just say person schema, I tell sort to save it, to pass it in a safe way, which means it doesn't throw an error if something fails, just pass the person, do it, and then I have here the success property, which will tell me if this is a real person or if it is, or if it's not the case. And then I have a very type safe type predicate, which is very easy to write and also very safe to use. And I could now use it even if we're dealing with unknown types. But as I said before, there's more or less, let's not just think about the worst cases. That's why I'm going to switch back, because I want to show you something else, and then we are already done with it. So what did we have? We had the undefined, we had the string, we had the person, and we also had the person JSON. What I said before is this return null. I don't want that. I don't want that the null is returned, and if I would just return something and TypeScript is complaining, I would have to say, okay, then I'm returning undefined, which honestly speaking isn't that much better. But there is an alternative to that. If you have these use cases, just throw an error. It's just that easy. Just throw error, because in this case, I mean, this happens quite often, that we are getting some type from a library where we know it can never be the case that a null or an undefined is passed. If that's the case, then something else went already wrong, and then it's time to throw an error in order to be aware of it. So in this case I say null or undefined not allowed, or something like this. And then you can get rid of the undefined, or you can also do something else. Because if you need this check quite often, you don't need to repeat it all the time. There is something in TypeScript which has a very similar name, like the type predicate, or looks very similar. And this is the assertion function. And with the assertion function, it's not that we're returning a Boolean, but what we say to TypeScript, look, if you call this function, then we guarantee you that afterwards that type will be of type person, will be of type string, whatever. In my case, it's a little bit more complicated, because I say it can be everything, but it will not be null or undefined, because this is what the first if condition is doing here. And that's why I need to come up with a generic function. So I call this function is not nullable. I say it has some kind of type. You pass me the type, whatever it is. I don't care. But what I will guarantee you, and this is again, we are not returning or defining here a type as the return, but we say this function asserts that the value, and now there's a trick, because I want to say it can be everything except null or undefined, and there is a type utility in TypeScript which is called non-nullable, and I pass it here, or I use it here, and then, well, I need to throw an error if it is null or undefined. This is the compromise more or less. So TypeScript says, okay, I'm running it, and after that it will not be null or undefined anymore, but you have to make sure that you're throwing an error, or that you're dealing with the situation in any way, or what way you find best for it. Good, then I just say if the value is undefined, or if the value is null, then I want to throw the error that we have seen here. And then instead of using a first if condition, I can just say assert. Actually, yeah, this is what I've missed. We should call the function assert to make it better readable. Assert is not nullable. I say here value, and then I can actually get rid of this. It's just the if, because by now, as I said, the value will not be null or undefined anymore, And if we scroll down, or if we go down a little bit, we see here that it's just working as it should be. So a very handy function, which is, at least I use it quite often. Okay, so let's sum up. We have seen, from my opinion at least, the most important type guards that are available in TypeScript in order to come up to full type-safe code. Again, try to avoid the type assertion. As you've seen before, there are some situations where it's not always possible, but always try to go with type narrowing in the first place. We have seen the typeof. Returns the type if it's a primitive type, otherwise it returns object. Be aware of the null. We have seen the instanceof. It only works against class instances, but not against object literals, like the type person JSON and the type person here in this case. When you have these kind of situations where you're dealing with multiple object literals, then you can use the in operator, or the in type guard, where you really can request if this property is available. You can also use a discriminated property where you say, okay, you have different types, but you know they all have this property in common, and then you just check if the value is has the value that only is available for that particular type. TypeScript also understands this, and if all breaks, if all fails, then you can always go with this type predicate. That's the one. And as I said, this is some kind of a compromise where TypeScript can't help you anymore, and it says, look, you come up with your narrowing function, more or less, and I will trust you. And if it's really a little bit complicated, then as I said, just go with sort. But with all these techniques, I think you're very well equipped in order to come up with high quality code, which is, let's say, type safe as much as possible, as it is currently possible in TypeScript. All right, so this was it about type narrowing. Again, always use it over type assertion, because we have quite often a situation where we're dealing with multiple types and we need to specify or come down to one type only. Type narrowing is the type safe way, type assertion is the not so type safe way, and actually we are using TypeScript because we want to be type safe, otherwise we would have gone with JavaScript. So it's just logical that this is the most important skill, in my opinion, for application developers. If you're on the other side, if you're a library developer, or if you are working on shared parts in your application that are used in different areas, then you're actually also a library developer. And in that case, other skills are also as important. They are the generics, the conditional types, the map types, the template literal types, and well, then you have to learn them as well. But for application developer, it's, in my opinion, only about type narrowing, because application code should be very specific, whereas library code should be more generic. So if you have another opinion, please let me know. I would be very interested in that. If you have any questions, then also please don't hesitate, just ask, write a comment. And well, that's it. Thanks for watching, of course, and see you in the next video. Goodbye.